Hi students, friends, good afternoon to all. I welcome you all in this fluid mechanics lecture. So in the last lecture, we have studied the point. It was about the viscous flow or laminar flow through the pipes, right? And here we have written the formulas for velocity distribution, then for the shear stress distribution, and then ratio of maximum velocity to average velocity that we have noted down. Then drop of pressure for the given length of pipe, and we have solved the problem. In today's lecture, we will see the next point, that is flow of viscous fluid between the two parallel plates. Here we are going to note down the formulas for this velocity distribution, then shear stress distribution, then relation between maximum velocity and average velocity, right, and pressure difference between that. The same points are there, but these are applied to the viscous fluid flow between the two parallel plates. Okay, so write down the title in your notebook: flow of viscous fluid between two parallel plates.
सर लिंक सेंड केलं नाही तुम्ही ग्रुपवर. मी 5th मार्चच्या लिंक वरून जॉईन केलं.
ग्रुप वरती लिंक सेंड केली टाकलेत की नेट बंद होतं माझं ते ओके गेली बंद. So here we will see now so after writing this title, draw this diagram. Draw the diagram for these two plates. Then this is one fluid element which has been shown here of sides A, B, C, D. The distance between these two plates is given as h, small h. The direction of flow is this. This is the direction of flow. The pressure is going to act on these fluid elements on this side also, as well as on this side. The thickness of this small plate, small fluid element, is delta y. The length is delta x. The velocity distribution for the viscous flow between two parallel plates is given by equation u is equal to, write down the title there after that, velocity distribution, and write down this equation. All of you have you noted down this formula? Okay. Then shear stress distribution, right on the title, shear stress distribution, write on this formula. Tau is equal to minus 1 by 2 del P upon del X in bracket small h minus 2y. See here, this velocity, this is the diagram for velocity distribution. This is the diagram for shear stress distribution. If you look the diagram of the pipe flow, viscous flow through the pipe and viscous flow through the parallel plates, you will come to know that this velocity profile and shear stress distribution, these are similar. Okay. In case of pipe flow, there was a what kind of curve it was? Parabolic curve. And here, uh, this is the shear stress distribution. At the center, the velocity will be maximum, and at the surface, the velocity is minimum or it is zero. Similarly, in case of shear stress is minimum at the center, and it will go on increasing toward the surface. At the surface, it is the maximum. Okay, this is the formula to find out the shear stress. If you put the values of y here in this equation, y 1, 2, 3, 4 like that, we can reach up to the h. And when we put the value of h here, what will get here? We will get the maximum shear stress. So what is the value of maximum shear stress? H is varying from here. Na? What is the maximum value for the shear stress? Tau max is equal to. This is the equation for tau max. If we put here h is y is equal to h, जर आपण या ठिकाणी टाकलं तर काय होईल हे? This will become minus h. Okay, and this is 2 is there, so it will be minus del p upon del x into h by 2. So this is the formula for tau max. You can note down this formula also. Tau max, that is maximum shear stress. Tau max is equal to minus del p upon del x into h by 2. Then maximum velocity. U max is equal to U max is equal to minus 1 by 8 mu into del p upon del x into h square. Next, ratio of maximum velocity to the average velocity. U max upon U bar is equal to 3 by 2. In case of pipe flow, what was the formula? Anyone remember? It was 1 by 2. Maximum velocity is twice the average velocity. Oh, this is not 1 by 2, it is equal to 2. Here, this value is nothing but it is 1.5. And for the pipe flow, it was equal to 2. Means U max is equal to 2 times of the average velocity. Pipe flow ची आपण जर इक्वेशन बघितली तर तुम्हाला लक्षात येईल त्या ठिकाणी. This is for the parallel plates. Next, drop of pressure for given length of pipe. drop of pressure. So P1 minus P2 असा फॉर्म्युला पण त्या ठिकाणी लिहिलं होतं. 12 mu u bar L divided by h square. Write down this formula. P1 minus P2 is equal to 12 mu u bar L divided by h square. If you divide both side by rho z, दोन्ही साइडला जर आपण या ठिकाणी rho z ने डिवाइड केलं like this, then this will be called as the HF. Okay, that is head loss due to friction. So to find out the head loss due to friction, we have to use this formula. So you can write down this formula. HF is equal to 12 mu u bar L divided by rho z h square. First write down this formula and then this. HF is equal to 12 mu u bar L divided by rho z h square. Yeah. Now here we will solve one problem based on these parallel plates, okay, stationary plates, by using same formulas that we have noted down now. We will solve one problem and then we will move toward the next point. Write on the problem. Calculate first the pressure gradient along flow. Calculate pressure gradient along the flow. Comma, the average velocity and third the discharge for an oil of viscosity 0.02 Newton second per meter square flowing between two stationary parallel plates. Flowing between two stationary parallel plates, 1 meter wide, maintained 10 mm apart. So the distance between two plates is 10 mm, that is 1 centimeter. The velocity midway between the plates is 2 meter per second. So what is this velocity midway between the plate means? It is Umax, maximum velocity, because velocity will be maximum at the center or midway, right, between the plates, and it is given as 2 meter per second. So here we have to calculate pressure gradient, that is P1 minus P2 divided by L, or del P upon del X. Then average velocity we have to find out, and discharge for an oil of viscosity. So first of all we will write down the given things. mu is equal to 0.2 is it 0.2 or 0.02? A 0.2 Newton second per meter square. Width B is equal to width of the plate B is equal to 1 meter. Distance between the plates H is equal to 10 mm or 0.01 meter, and U max is equal to 2 meter. U max. Now first we have to find out what is pressure gradient. Okay. So whatever the formulas we have written earlier, we have to check there in how many formulas, which are that formulas in which del P upon del X is there. So this is the first formula where pressure gradient is there, del P upon del X. Right. Check any other formulas there. U max and tau formula is there. So these two formulas we can use. Okay, or this third one also, tau max is equal to. But if you look these formulas, we need to find what is shear stress, or it should be given, or maximum shear stress should be given if you want to use this formula. H is given, we can put this value of H, but what about the tau max? It is not given, or tau is not given, H is given. So here we will go to use this formula because U max is given, midway velocity is given, viscosity is given, and distance between the two parallel plates is given. So putting these values, we can find out what is the value of del P upon del X. Okay, so use this formula and find out what is the del P upon del X. See here, viscosity is 0.02 Newton second per. Okay, so या ठिकाणी correction करा. Given मध्ये 0.02. So del P upon del X is equal to minus this much per meter length you will get. So why this minus sign is there? This minus sign, it shows that pressure intensity it decreases along the length. Okay, या ठिकाणी प्रेशर इंटेन्सिटी जास्त असेल, प्रेशर ग्रेडियंट विल बी मोर, आणि जसं आपण पुढे जाईल तशी प्रेशर इंटेन्सिटी कमी कमी होत जाते. व्हॉट इज द रिझन? ड्यू टू द हेड लॉस. ते विस्कॉसिटीमुळे त्या ठिकाणी जो होणारा हेड लॉस आहे, त्या हेड लॉसमुळे त्या ठिकाणी प्रेशर इंटेन्सिटी कमी होते. So all of you got this value? Next, average velocity. Average velocity चा फॉर्म्युला तुम्ही लिहून घेतलेला आहे. U max divided by U bar is equal to 3 by 2. This formula you have noted down there. So you can write like this also. U max is equal to 1.5 U bar. So U bar will be equal to U max divided by 1.5. So U max is equal to 2 divided by 1.5. You will get here 1.33. Check whether you have got this value or not. Is it over? Then we want to find out what is the discharge. Okay, discharge for an oil of viscosity असं दिलेलं आहे. याचा डिस्चार्ज आपल्याला क्यू काढायचा आहे. क्यू काढण्यासाठी आपल्याकडे दोन फॉर्म्युले आहेत. एक आहे व्हॉल्यूम पर युनिट टाइम. ओके, आणि दुसरा फॉर्म्युला आपल्याकडे आहे Q is equal to area into velocity. Okay, average velocity that we take here. So out of this formula, we have to check which formula it can be applicable here. Okay, whether the volume is given in the problem or anything value which is related to the volume, whether it is given the problem, then we have to go for this. If it is not, then we have to look for this. Whether area between these plates, can we find? See, this is one plate, this is another plate. This height is given to you, h. Okay, and they have given the value of width of the plate. The plate ची width दिलेली आहे. ही plate आहे ती अशी आहे. Okay, so the area between the plate we can find easily. This is the area, means this width multiplied by h. Okay, b into h, you will get here area of flow, and that area of flow is nothing but this is a, and this v is nothing but it is average velocity u bar. Okay, if you put this value here, you will get the discharge. Q is equal to what is h, that is 0.01 into b, width is 1 meter. You will get here 0.01 meter square. So the area, okay, multiplied by velocity. What is the average velocity? It is come 1.33. So 1.33 multiplied by area, cross section area. कुठे काढला आपण तो? B into H. This is 0.02 into 1. This is the A actually. Okay. So this cross section area 0.01. It will come here, multiplied by this velocity. You will get the discharge Q is equal to 0.0133 meter cube per second. Is there any doubt in this problem? Any difficulty, any query? Solve it. Is it over? Done? Okay. Now we'll move toward the next point, that is turbulent flow. So whatever the first point we have studied here, it was about the viscous flow or laminar flow. And here we have seen various conditions like viscous flow flowing through the circular pipe, right? And liquid viscous flow taking place through the parallel plates, stationary parallel plates and circular pipe. याचे वेगळे फॉर्म्युले आपण या ठिकाणी बघितलेत, like velocity profile formula, then shear stress formula, then Vmax upon U average velocity formula, then P1 minus P2 at pressure difference formula, then tau max formula. So these are the various formulas we have seen derived and we have seen here, and we have solved the problem based upon this. Now here we are going to study the turbulent flow. Turbulent flow means everyone knows what is that. There is a turbulence in the flow. Okay, the path of the fluid particle is zigzag, right? So we have written there the definition of turbulent flow and laminar flow, right? So in case of laminar flow, the loss of pressure head was found to be proportional to the velocity. But in case of turbulent flow, the Reynolds observed that the loss of head is approximately proportional to the square of the velocity. ओके, हा पॉइंट मी तुम्हाला मागच्या लेक्चर मध्ये सांगितलं होतं. त्या ठिकाणी एच एफ जो आहे फॉर्म्युला एच एफ चा, त्याच्यामध्ये व्ही ची पॉवर जी आहे ती 1 होती आणि हेड लॉस ड्यू टू फ्रिक्शन मध्ये व्ही ची पॉवर जी आहे ती त्या ठिकाणी 2 आहे, 2 होते. ओके, इट इज डायरेक्टली प्रोपोर्शनल टू द व्ही स्क्वेअर. ओके, हियर इट इज डायरेक्टली प्रोपोर्शनल टू व्ही. More exactly, the value of loss of head HF is directly proportional to V raised to n, where n varies from 1.75 to 2. But generally we take this value of n as a 2 only, and that's why in various formulas we get the power here as a square. Like in case of Darcy-Weisbach equation, what is the equation? 4FL V square upon 2ZD, right? So this head loss here, it varies directly proportional to the square of the velocity. Okay, now here frictional losses in the pipe flow, that point we will see now. Expression for the loss of head due to the friction, this equation where we have seen, yet to see, I think we have not yet derived this equation. We are going to derive this equation in coming points. So in case of turbulent flow, the loss of head is given by this equation. Okay, and also expression for the coefficient of friction is in terms of shear stress, F is equal to, so it is given like this. So this equation we will derive afterwards. Shear stress in the turbulent flow. So now in case of viscous flow, we have studied the Newton's law of viscosity, and there that Newton's law of viscosity, it says that shear stress tau is equal to mu into du by dy. So this law or this equation is applicable for viscous flow only. Okay, so that's why this tau v is nothing but it is the shear stress in the viscous flow. Okay, due to the viscosity. Similarly, if there is a turbulence in the flow, so the scientist Bozinsk, he has given the expression for the turbulent shear stress. So this tau into t, tau t, okay, suffix is there. Tau t is nothing but it is the shear stress due to the turbulence, and this tau v is nothing but it is shear stress due to viscosity. So he has given the equation similar to the shear stress due to the viscosity, that tau t is equal to eta into du bar by dy. So what is this eta here? The eta is nothing but it is the eddy viscosity. So here we call it as a dynamic viscosity. Here this eta is nothing but it is the eddy viscosity. Tau t is nothing but it is the shear stress due to the turbulence, and u bar is nothing but it is the average velocity at a distance y from the boundary. Okay, बाउंड्री पासून किती अंतरावरती तो आपण त्या ठिकाणी मेजर करतोय, फाइंड आउट करतोय shear stress. Okay, this is the y. Now we can club these two equations so that we can consider both the what you can say shear stresses due to the viscosity as well as due to the turbulence. The ratio of eta, eddy viscosity, to the rho is known as the kinematic eddy viscosity. जसं डायनामिक विस्कोसिटी मध्ये आपण काय म्हटलं होतं, mu upon rho is nothing but it is kinematic viscosity nu, right? Nu is equal to mu upon rho. Similarly here, this epsilon is nothing but it is the kinematic eddy viscosity. This is just kinematic viscosity. This is kinematic eddy viscosity. This is given by equation epsilon is equal to eta divided by rho. So you can see the similarity between these two. In the denominator there is rho, here also rho. In the numerator there is a dynamic viscosity, and here this viscosity is nothing but it is kinematic eddy viscosity. And then if you combine these two, then you will get the total shear stress. Tau is equal to shear stress due to viscosity, shear stress due to the turbulence is equal to these parts we have taken here. Okay. For the laminar flow, जर फ्लो लॅमिनार असेल तर त्या ठिकाणी एडी विस्कॉसिटी नसणार आहे, इट विल बी 0, and that's why this part will get cancelled and you will get only this value. Okay. And for the other cases where eta it may be available there, in that case we have to use this formula. So this Bozinski has given this equation for the shear stress, but this equation was having some limitations, and due to which other scientist Prandtl, he has come up with the other equation for the shear stress. Reynolds, okay, before Prandtl, Reynolds, he has given the equation in 1886. Okay, what is that equation? Tau is equal to rho into u dash into v dash, where u dash and v dash are the fluctuating component of the velocity. Okay, in x direction, if the velocity component in x direction will be u, velocity component in the y direction it will be v. Okay, as u dash and v dash are varying and hence tau will also vary. ज्यावेळेस u dash आणि v dash vary होतात त्यावेळेस सेट tau पण त्या ठिकाणी काय होतं, बदलतं. Hence to find the shear stress, the time average on both sides of the equation is taken. मग या दोन्ही साईडला काय केलं जातं, टाइम एव्हरेज त्या ठिकाणी कॅल्क्युलेट केलं जातं आणि त्याप्रमाणे व्हॅल्यू या ठिकाणी काढली जाते. Then equation become as tau bar is equal to, so this when bar is applied here, this is the average value. Okay, so tau bar is equal to rho u dash into v dash bar. So this is the time average they have taken here to find out the shear turbulent shear stress by using the Reynolds equation. Then Prandtl, he has come with another theory which is called as the mixing length theory, and he has proposed this theory like this. So this u dash and v dash bar, it is very difficult to measure. To overcome this difficulty, L. Prandtl in 1925 presented a mixing length hypothesis which can be used to express turbulent shear stress in terms of measurable quantities. Okay, according to this Prandtl, what is mixing length? So this mixing length is nothing but it is the distance between two layers. Distance between two layers in the transverse direction. If the flow is taking place in this direction, transverse direction means perpendicular direction here. The distance between two layers in the transverse direction such that the lumps of the fluid particles from one layer could reach the other layer, and particles are mixed in the other layer in such a way that the momentum of the particles in the direction of x is same. Okay, हे डिस्टन्स जे आहे हे डिस्टन्स म्हणजे असं डिस्टन्स आहे ज्या ठिकाणी मिक्सिंग होत आहे, आणि हा जो मोमेंटम आहे, दिस मोमेंटम ऑफ द पार्टिकल इन द डायरेक्शन ऑफ एक्स, म्हणजे या डायरेक्शन मध्ये तो जो मोमेंटम आहे तो कसा असतो, फिक्स राहतो. So as it was very difficult to use this value, average value of the product of u dash and v dash, he has come with this Prandtl length, and u dash has been given by this formula. U dash is equal to L into du by dy, and similarly v dash is equal to what? V dash is equal to u into du by dy. Okay, and then if we put these values here in this equation, then we will get L into du by dy into L into dy by dy. So here we got this value L dash square L square into du square du by dy whole square. So after that, putting these values in this equation, या इक्वेशन मध्ये जर आपण टाकून दिली तर आपल्याला हे भेटेल. Tau bar is equal to rho L square du by dy bracket square. Okay. So thus total shear stress at any point in turbulent flow is the sum of shear stress due to the viscous shear and shear turbulent shear. So here in this equation, this is the viscous shear and this is the turbulent shear equation. या दोन्हीची ऍडिशन केल्यानंतर आपल्याला टोटल शियर स्ट्रेस हा या ठिकाणी भेटून जातो. Then we are going to learn the new point, that is hydrodynamically smooth and rough boundaries. Before that, in your notebook, write down the titles. Write down there turbulent flow title. Yeah. This सांगितलं. So write down there expression for head loss due to friction in the pipe. हे डेरिवेशन आपण नंतर बघणार आहोत. HF is equal to 4FLV square upon 2ZD, where F is the coefficient of friction. Then how to find out this F? So write down there coefficient of friction in terms of shear stress. Small f is equal to 2 tau 0 upon rho v square. See, Darcy-Weisbach, this equation is called as the Darcy-Weisbach equation. This equation can be written like this also, that we are going to derive, we are going to see there. When it is written like this, at that time, this F is called as the friction factor. And when it is written with the 4F like this, then it is called as the coefficient of friction. Write on the title, shear stress in the turbulent flow. Directly write down your equation, heading that total shear stress in the turbulent flow is given as write down this equation. Where T suffix where T suffix V, that is TV here, is nothing but shear stress due to viscosity. Then TT is nothing but shear stress due to turbulence. Then mu is equal to dynamic viscosity. Mu is equal to dynamic viscosity. Epsilon is equal to, not epsilon, it is eta. This symbol. Eta is equal to eddy viscosity okay. Then write down title Reynolds expression for turbulent shear stress. Reynolds expression for turbulent shear stress. Write down this equation. Tau is equal to rho into u dash v dash, where u dash comma v dash is equal to fluctuating component of velocity in the direction of x and y due to turbulence. Write down there below. As u dash and v dash varies, as u dash and v dash varies, hence tau also varies. Hence, to find shear stress, comma, the time average on both sides of equation is taken. Then equation become as tau bar is equal to rho u dash v dash bar. Next title, Prandtl mixing length theory. Prandtl is the name of that engineer or scientist. Prandtl mixing length theory for turbulent shear stress. Prandtl mixing length theory for turbulent shear stress. Directly write down this equation. Tau bar is equal to mu into du by dy plus rho L square du by dy bracket square. Now here we are going to see the next point, that is hydrodynamically smooth and rough boundary. Okay, so write on the title. Hydrodynamically smooth or rough boundary. See, if we take any surface, कुठलाही सरफेस आपण जर घेतला, कितीही स्मूथ सरफेस असेल, तो जर आपण मायक्रोस्कोप जर मधून पाहिला तर त्याच्यावरती आपल्याला इरेग्युलरिटीज पाहायला भेटतील. ठीक आहे. So likewise irregularities will be present on the any surface. PVC पाईप घेतला किंवा आपण मेटल पाईप घ्या, स्टील पाईप घ्या, HD पाईप घ्या किंवा MS पाईप, GI पाईप, you will observe at least very small amount of such kinds of irregularities present on the surface when we look it under the microscope. Okay, and due to this irregularities there is a formation of such kinds of this, due to the viscosity there is a formation of this what we can call boundary layer. Below this boundary layer, तर हे डायग्राम जे आहे ते अर्धीच डायग्राम आहे ऍक्च्युली. जर असा पाईप असेल तर त्या पाईपच्या नियर सरफेस मध्ये या ठिकाणी अशी एक लेअर, बाउंड्री लेअर तयार होते. ओके, त्याला आपण बाउंड्री लेअर थिकनेस म्हणतो. त्याच्यामध्ये जो फ्लो आहे हा विस्कस फ्लो असेल, त्याच्यामध्ये विस्कस फ्लो असेल, आणि बियॉन्ड दिस हा जो पार्ट आहे एवढा, त्याच्यामध्ये फ्लो जो आहे दिस फ्लो इज टर्ब्युलंट फ्लो. ओके, हा जो पोर्शन आहे दिस थिकनेस इज कॉल्ड एज द बाउंड्री लेअर थिकनेस or boundary layer, this portion. And here shear stress will be tau v, and here shear stress will be tau p. Okay, now this laminar sublayer, or this is the boundary layer below which the flow is laminar and beyond which flow is turbulent. Jar this thickness k, this k is nothing but it is the average irregularities, average height of the irregularities. त्याच्या irregularities या ठिकाणी दाखवले आहेत. Suppose this height is k1, its height is k2, its height is k3. या सगळ्यांची जर आपण ऍव्हरेज काढली तर and if we represent it by k, then this k is called as the average height of the irregularities. Okay, if this average height of irregularities it is smaller than this del dash, that is bound laminar sublayer, then this pipe is called as the smooth pipe. Okay, आणि जर ह्या के जो आहे average thickness, average height of the irregularities, if its value is greater than laminar sublayer, ह्या laminar sublayer च्या वरती जर जात असेल त्याची height, average height, okay, then this boundary is called as the rough boundary and this boundary will be called as the smooth boundary. Okay, कशावरून ठरवलं आपण ते? It depends upon the value of k, that is the average height of irregularities projecting from the surface, which average height. Okay, if it is less than the laminar sublayer, then this boundary is called as the smooth boundary. If the k is greater than the laminar sublayer, then this boundary is called as the rough boundary. Okay, so draw the diagram in your notebook. Title लिहिल्यानंतर त्याची खाली ती diagram काढायची, smooth and rough boundaries. If the drawing the diagram is over, then we will move toward the next point. Shall I take the next slide?
Yes.
Variation of coefficient of friction. Again, this is the point from the turbulent flow. Variation of coefficient of friction. So here, this coefficient of friction, it can be obtained. It can be found by using these two formulas. If the flow is turbulent, त्याच्यामध्ये परत जर पाईप स्मूथ असेल turbulent flow मध्ये, in that case we have to go for this formula to find the value of f. Coefficient of friction ची व्हॅल्यू कशी फाइंड आउट करायची? बाय युजिंग रेनॉल्ड्स नंबर. ओके, त्याचा वापर करून हे स्मूथ पाईपची कोएफिशिएंट ऑफ फ्रिक्शन जो आहे तो आपण त्या ठिकाणी फाइंड आउट करू शकतो. जर पाईप रफ पाईप असेल त्या केसमध्ये द व्हॅल्यू ऑफ कोएफिशिएंट ऑफ फ्रिक्शन it can be obtained by using this formula. 1 upon under root of 4f is equal to 2 log to the base 10 r by k plus 1.74. What is this r and what is this k? R is nothing but it is Reynolds number. Okay, and this k is we have just already written there. K is nothing but average thickness, average height of the roughness. Okay, so note down these two formulas. Title हे variation of coefficient of friction हे टायटल लिहिल्यानंतर त्या ठिकाणी हा पॉइंट लिहा 1 F for smooth pipes, F for smooth pipes, and then we can directly write down this formula. Sometimes in problem they will not give you the value of coefficient of friction. प्रॉब्लेम मध्ये आपल्याला कोएफिशिएंट ऑफ फ्रिक्शन ची व्हॅल्यू दिलेली नसते, ते आपल्याला काढायची असते. जर स्मूथ पाईप असं मेन्शन केलं असेल त्या केस मध्ये आपण हा फॉर्म्युला वापरून हे कोएफिशिएंट ऑफ फ्रिक्शन ची व्हॅल्यू फाइंड आउट करू शकतो फॉर दॅट पर्टिक्युलर पाईप. ओके, स्मूथ पाईप साठी. Then they may not give the value of Reynolds number also. You have to find out the value of Reynolds number first by using formula rho vd upon mu. हा फॉर्म्युला पूर्ण अगोदर रेनॉल्ड्स नंबर काढायचा. त्यानंतर जी काय व्हॅल्यू आली रेनॉल्ड्स नंबरची वी हॅव टू चेक वेदर इट इज ग्रेटर दॅन 4000 और नॉट. जर ती 4000 पेक्षा ग्रेटर असेल तरच आपल्याला हा फॉर्म्युला त्या ठिकाणी वापरता येतो, कारण तरच तो फ्लो आपला काय टर्बुलंट फ्लो होईल. ठीक आहे. Then after finding this value of Reynolds number we have to put this value here and then you will get the value of f. Okay, then write down their second title here, the value of f for rough pipes. The value of f for rough pipes. Write down this formula. Yes. एक minute. काय म्हणता? Newton? No slip condition. हो आहे. आपण बाउंड्री लेयर केली म्हणजे आपण शिकणार आहोत. Okay. After this, we are moving toward the next point, that is loss of energy or loss of head in the pipes. Okay. So what are the various types of losses that you have come across, you have learned till now? You have already studied these things in the diploma. That's why I have told you before sometimes that these things are uh, known to you. You will be either familiar to you. There are two types of losses that takes place through the pipe. When the liquid flows through the pipe, at that time, there are the losses which takes place there. That can be categorized, classified into types or two categories. First one, that type of loss is called as the major loss. Okay. And second one, it is called as the minor losses. Okay. What is the major loss? Major loss कशाला म्हणायचं? The loss which takes due to the friction. Friction मुळे जो होणारा जो loss आहे, that loss is called as the major loss, and it is also called as head loss due to friction. Right? And which we denote it by letter HF. Okay. As this loss is very large in quantity, that's why the name it has been given as major loss. Okay. Minor loss. It is the collection of different types of losses which takes place in the pipe due to change in velocity, change in magnitude or direction of the velocity. जर velocity ची त्या ठिकाणी डायरेक्शन बदलत असेल, त्याच्यामुळे होणारा जो लॉस आहे, किंवा velocityची मॅग्निट्यूड जर त्या ठिकाणी बदलली, तर त्याच्यामुळे जो त्या ठिकाणी लॉस क्रिएट होतो, that loss is called, that types of losses, they are called as the minor losses. Okay. So what are the various types of minor losses that are there inside the pipe? The first one is the head loss due to sudden expansion. Okay, हे डिटेल मध्ये आपण नंतर बघणार आहोत. जर सडनली पाईप त्या ठिकाणी डायमीटर वाढली, तर या ठिकाणी जो होणारा लॉस आहे, that loss is called as the head loss due to sudden expansion. After that, head loss due to sudden contraction. म्हणजे मोठ्या पाईप मधून लहान पाईप मध्ये जर पाणी चाललं असेल, तर या ठिकाणी होणारा जो लॉस आहे, दिस इज द लॉस कॉल्ड एज द हेड लॉस ड्यू टू सडन कॉन्ट्रॅक्शन. हेड लॉस इन द बेंड्स. ज्यावेळेस डायरेक्शन बदलते पाईपची, त्या ठिकाणी आपण बेंड, एल्बोज हे वापरतो. मग या ठिकाणी जो लॉस होतो, that loss is called as the head loss in the bed. Next one is the pipe fittings. पाईप मध्ये आपण जे वेळेला फिटिंग्स वापरतो, रिड्यूसर असेल, ओके, किंवा कपलर असेल, किंवा वेगळ्या टाईपचे वॉल्स असतील, ठीक आहे, त्याच्यामुळे जो त्या पाईप मध्ये होणार लॉस आहे, that loss is called as the head loss into pipe fittings. And last one, an obstruction in the pipe. जे पाईप मध्ये पाणी फ्लो असताना जर मध्ये काही एखादा अडथळा असेल, त्याच्यामुळे पण त्या ठिकाणी हेड लॉस होतो, and that loss is called as the head loss due to an obstruction in the pipe. Okay, so this is the major loss and minor losses. So first we will see the major losses in details. Major loss, to find out the major loss, we have the different formulas. Out of that, two formulas are more famous. One is called as the Darcy-Weisbach equation, and second one is the Chezy's equation or Chezy's formula. Out of these two formulas, this is the use for the pipe flow, and this generally it is used for the open channel flow also, okay, and as well as pipe flow. So you can note down this chart here in your notebook. Write down the title, loss of energy or loss of head in pipes. Then write down that chart, energy losses or head losses. लक्ष तिकडे जाते की इकडे असते Is it work? हे आपण नंतर बघणार आहोत डिटेल मध्ये. आपण एक एक पॉइंट या ठिकाणी बघूया. फर्स्ट या ठिकाणी मेजर लॉस किंवा फ्रिक्शनल लॉस इन द पाइप फ्लो. राइट ऑन दिस टाइटल. Major loss or frictional loss. Why this occurs? The reason behind this major loss is the viscosity. Frictional resistance for turbulent flow. See, to find out this major loss or head loss due to friction, the scientist William Froude, he has done various experiments, and from his experiments he has obtained certain laws. Okay, and these laws have been given here that you have to note down. The frictional resistance for the turbulent flow is, the frictional resistance आहे, the main reason behind that is viscosity, and this frictional resistance जे laws आहेत ते आपण या ठिकाणी लिहून घ्यायचे. So write down there the frictional resistance for turbulent flow is, first point, proportional to the v to the power n, proportional to the v raised to n, where N varies from 1.5 to 2. N varies from 1.5 to 2. Then second point, this frictional resistance is proportional to the density of the fluid. Proportional to the density of the fluid. That is rho. It is proportional to the area of surface in contact. Then it is independent of the pressure. Last one, it is dependent on the nature of the surface in contact. Now here there is expression for head loss due to friction in a pipe. Write on the title, expression for head loss due to friction in a pipe. See here, I will explain you the derivation. Not needed to write down this. Okay, just listen. Here, to find out this expression for head loss due to pipe, we have to consider two sections here, section 1 and section 2. So pressure here will be called as P1, velocity V1, diameter D1, area A1. Similarly here, pressure P2, area A2, velocity V2, right? And the distance between these two sections is L. या दोन्ही मधला जो distance आहे, that distance is L. Then F dash is nothing but it is the frictional resistance per unit weighted area per unit velocity. Okay, per unit weighted area means आतला जो ओला झालेला सरफेस आहे एरिया आहे that is called as the weighted area per unit velocity. So this frictional resistance per unit weighted area per velocities, that is the F dash, and HF is nothing but it is the loss of head due to the friction. Now here what we are going to do, we will apply the Bernoulli's equation between these two sections, section 1 and 2, as this pipe is horizontal pipe. Okay, here first of all we will apply this Bernoulli's equation between these two. What we will get here, P1 upon rho g plus, P1 upon rho g plus V1 square upon 2g plus Z1 is equal to P2 upon rho g plus V2 square upon 2g plus Z2. As pipe is horizontal, this Z will get cancelled. As pipe is of the uniform diameter, means there is no change in the diameter. The velocity here V1 and V2 will be same, and that's why their square this will be same. So this again this will get cancelled. Okay, plus या ठिकाणी आपल्याला HF लिहायचं राहिलं आहे किंवा HL हेड लॉस. ओके, पाणी ज्यावेळेस इथून इकडे जाईल त्यावेळेस या ठिकाणी जो हेड लॉस होतो that we have to add it here. This is the modified modified Bernoulli's equation that we have seen. So this HL or HF will be equal to, now if I take this P2 here, what I will get, P1 upon rho z minus P2 upon rho z. That is head loss, this pressure head in the section 1 minus pressure head in the section 2. Here you can see this HF is equal to pressure head in the section 1 minus pressure head in the section 2. But HF is due to HF is the head loss due to friction, and hence intensity of pressure will be reduced in the direction of flow. Okay. Now this frictional resistance जो आपण वरती लिहिलेला आहे F dash. This frictional resistance is nothing but it is the this F dash into, that is frictional resistance per unit weighted area. जर आपण ह्याला weighted area ने मल्टिप्लाय केलं, ठीक आहे, into velocity square, तर आपल्याला काय भेटतो, frictional resistance भेटतो. So that's why F1 is equal to, I will write here F dash into this weighted area is nothing but pi d into शिंदे. काय बोलते रे? F dash into pi d L. What is this pi d L? Weighted area. Pi d is nothing but perimeter. Okay, perimeter of the weighted perimeter. त्याला जर आपण लेंथ ने मल्टिप्लाय केलं तर आपल्याला काय भेटेल, weighted area भेटेल. Okay, pi d L into this v square, velocity square, I will write here. So F dash into this pi d is nothing but it is perimeter. So I will write here P and this LV square as it is. Now the forces acting on this fluid between the section 1 and 2, कोणकोणते फोर्सेस ऍक्ट होतात त्या ठिकाणी? एक म्हणजे लेफ्ट साइडने ऍक्ट होणार प्रेशर फोर्स, राइट साइडने ऍक्ट होणार प्रेशर फोर्स सेक्शन 2 च्या ठिकाणी, सेक्शन 1 च्या ठिकाणी हा लेफ्ट साइडचा प्रेशर फोर्स. ठीक आहे. प्रेशर फोर्स ऍट सेक्शन 1 ओके, या ठिकाणी प्रेशर आहे P1, that is pressure intensity multiplied by area, so that is pressure force. So P1 into A. Here pressure force at section 2, pressure intensity multiplied by area, so pressure force will get here. And हे दोन फोर्स झाले, आणि तिसरा जो फोर्स आहे that is nothing but frictional resistance which is acting in opposite direction to the flow. Okay, frictional resistance जो आहे तो कधीही डायरेक्शन ऑफ फ्लोच्या अपोजिट मध्ये असतो. जर डायरेक्शन ऑफ फ्लो असे असेल तर फ्रिक्शनल रेजिस्टन्स हा इट विल ऍक्ट इन दिस डायरेक्शन. राईट. आता या ठिकाणी आपण डायरेक्शन ऑफ फ्लो अशी पकडली आहे, त्यामुळे फ्रिक्शनल रेजिस्टन्स आपला हा असा असेल, दॅट इज F1. हे तीन फोर्सेस या ठिकाणी ऍक्ट होत आहेत. P1A, या ठिकाणी P2A आणि हा F1, हे तीन फोर्स या ऍक्ट होत आहेत. सो इफ वी टेक देम collectively, so resolving these forces in horizontal direction, what will get, you will get this equation. राइट साइडला पॉझिटिव्ह डायरेक्शन, लेफ्ट साइडला निगेटिव्ह डायरेक्शन जर आपण घेतली तर राइट साइडचा हा पॉझिटिव्ह, लेफ्ट साइडला ऍक्ट होणारा हा निगेटिव्ह, आणि फ्रिक्शनल रेजिस्टन्स ऍक्टिंग इन लेफ्ट डायरेक्शन, सो इट विल निगेटिव्ह इक्वल टू 0. यातला एक कॉमन काढला तर आपल्याला भेटेल या ठिकाणी P1 minus P2 into A is equal to F1, and this F1, instead of this F1 I can write this. Okay, so P1 minus P2 is equal to, if I take this A on this side, so I can write here F dash into P into L into V square upon A. Okay. Now, but from this equation 1 म्हणजे P1 upon rho z minus P2 upon rho z is equal to HF. ही जी इक्वेशन आहे, फ्रॉम दिस इक्वेशन 1 I can write P1 minus P2. हा जर कॉमन घेतला मी, या दोन्हीचा बेस सेम आहे, I can write here common rho z, and if I take this rho z on this side, so I will get this equation P1 minus P2 is equal to rho g HF. Okay, so instead of this now P1 minus P2, I will put this rho g HF in this equation. So I will get here rho g HF is equal to F dash, हा part as it is, हा part या ठिकाणी कॅरी फॉरवर्ड होईल. हा rho g या ठिकाणी घेऊन जा, HF या ठिकाणी ठेवा. So I will get here F dash upon rho z, and this part will be as it is. Okay, carry forward. Then This P upon A is nothing but it is weighted perimeter upon area. This perimeter, we have equation for the perimeter is pi d, and for the area pi by 4 d square. If I put this, I will get here 4 by d. Okay, so instead of this, I can put here P upon A is nothing but 4 by d, but it is या ठिकाणी पण आपल्याला हे आहे तसं टाकता येईल. So what I can get here, and instead of this f dash upon rho, here I will write EF upon 2, where this F is nothing but it is coefficient of friction. Okay. So equation 4 will become HF is equal to 4F up 4. Okay. This 4 will come here. 4F. आता ह्या F च्या ऐवजी आपण काय केलंय, हा 2 खाली लिहिलेला आहे. 4F आणि हा रो या ठिकाणी कट झाला. 4F upon 2Z into P upon H आपण ठिकाणी काय टाकलं होतं आपण 4 by D. So here I can write divided by D. So 4F L V square upon 2Z D. So I will get this equation final. What is that? HF is equal to 4F L V square upon D into 2Z. This is our final equation. This equation is called as the Darcy-Weisbach equation. Okay. So this was the derivation for this Darcy-Weisbach equation. Now here, we are not going to note down all these things, but we will just write down the formulas. Sometimes this Darcy-Weisbach equation, it can be written in terms of friction factor. Okay. हा जो F आहे 4F, या ठिकाणी this F is nothing but coefficient of friction म्हटलेला आहे आपण. Okay. Some author, what they use, instead of this 4F, they use only F, and that F is called as the friction factor. Okay. So the relation between coefficient of friction and friction factor, what is that? Friction factor F is equal to 4 times coefficient of friction. So here you can use the symbol dash here. Friction factor is equal to 4F, that is 4 times coefficient of friction. So this thing we should keep in mind. So here, let us write down the equation for the Darcy-Weisbach formula. Okay, I think you have written this title directly. Write down this formula in your notebook. HF is equal to 4 FLV square upon 2ZB. So this 4 and 2, it may get cancelled here, but it is the way of writing this equation like this. Because in most of the equation, if you see there, this V square upon 2G part comes, and this V square upon 2G is nothing but it is the velocity head, or it is also called as the kinetic head. Have you written this equation?
Yes.
Then write down there equation number, the equation number 1, 2 by 3. So equation 1 is known as Darcy-Weisbach equation. Below that, write down this equation is commonly used for finding loss of head due to friction in the pipes. Next, sometime this equation is written as, sometime equation 1 is written as HF is equal to FL square upon D into 2Z. Then F is known as friction factor. In your diploma books, most of the problems they have used the friction factor term, not the coefficient of friction, if you remember. Is it over?
Yes, sir.
Now we'll solve Chezy's formula is there. We will see it and then we will solve the problems. After this, write down the title, Chezy's formula for head loss due to friction. Chezy's formula for head loss due to friction in pipe. Is it over? See here, from equation 10.3.1 means on the previous page here, whatever we have derived this equation here. So it has been carried forwarded. HF is equal to, we have got this equation here. Okay. HF is equal to F dash upon rho is equal into T upon A into L into V square. So by taking the reference of this, Chezy's formula is derived. Now we know that this A is nothing but it is weighted area, this P is weighted perimeter. Okay. And this ratio of A by P is known as, this ratio A by P is known as hydraulic mean depth, HMD, or it is also called as hydraulic radius. Okay. And some author, they use letter M to denote this hydraulic mean depth or hydraulic radius. And some author, they use the letter R. Okay. काही पुस्तकांमध्ये तुम्हाला त्या ठिकाणी आर लेटर दिसेल, काही बुक्स मध्ये तुम्हाला हे एम दिसेल, which shows the these terms for this particular word, hydraulic mean depth or hydraulic radius. Okay. And this hydraulic mean depth is nothing but it is ratio of A by P. If I put here values of pi by 4 d square and here pi d, then this pi will get cancelled, this d will get cancelled, and you will get here d by 4. Okay. Pi, right. खाली जाईल. हा डी तो वरती राहिलेला आहे, डी शिल्लक आहे तो डी, आणि हा 4 खाली गेलेला आहे. So instead of this A by P, I can write here D by 4. Okay. This can be used. Or instead of this, I can write R also, or M. Hydraulic mean depth, M is equal to A by P into D by 4. Substituting this A by P is equal to M. Okay. या इक्वेशन मध्ये जर आपण टाकलं तर you can see here it is P by A, it is not A by P. If I take this P here, it can be written like this. Okay. हा P मी वरचा खाली घेऊ शकतो या ठिकाणी. And now it has become A by P. Now here instead of this I can write here m. Okay, so 1 upon m. This a by p is nothing but 1 upon m. So that I have put here in this equation HF is equal to. Then I have taken kept this v square, or I have taken this v square here and HF here. Then I will get this equation like this: v square is equal to HF.
Here complaint करून or
किंवा हे v स्क्वेअर आपण या ठिकाणी ठेवलं असं कन्सिडर करूया आणि हे जो पार्ट आहे बाकीचा हा आपण इकडे घेऊन गेलो एम सी. ठीक आहे. then this equation will be written, can be written as v square is equal to hf into rho g upon f dash into m into 1 upon l. Okay, and if I just take this hf here, I can call it as a I can write it as hf upon l. This is nothing but it is the head loss due to friction per unit length. हा जो आहे हा काय आहे, head loss due to friction per unit length which shows the slope. Okay, हा slope दाखवतो hf आणि हा l, it shows the slope. Okay, and instead of this now hf upon l I can write there s. So this is the hydraulic gradient. याला आपण काय म्हणतो, hydraulic gradient म्हणतो. किंवा some author use the letter I, s or I. So v square is equal to rho g upon f dash, this part as it is, the same as it is, and this f याची rearrangement केल्यानंतर आपल्याला असं भेटेल. Now here taking the square root on both sides, I can write these terms like this. Okay, and this part, instead of this part, what is written, c is written. And what is this c? C is the constant which is known as Chezy's constant. याला आपण c ला काय म्हणतो, आपण Chezy's constant म्हणतो. hf upon l, this is nothing but it is equal to I, where this I is nothing but it is the loss of head per unit length of the pipe. 1 मीटर लेंथ मध्ये किती लॉस होईल, so that is nothing but I, or it is also called as hydraulic gradient. Okay, now substituting ह्याच्या ऐवजी c टाकला, ह्याच्या ऐवजी I टाकला, तर आपल्याला इक्वेशन काय भेटेल, we will get the final equation as v is equal to c into under root of mi, or some author they use the notation r and s. So this equation can be written as v is equal to c into under root of r into s. So this equation is called as the Chezy's formula or Chezy's equation. Okay, the value of this head loss due to friction, okay, and experimentally we can find the value of this c also, that is Chezy's constant. So this is the Chezy's formula. So I think you have written the title there, Chezy's formula for head loss due to friction. Now here you note down there काय लिहिता येईल आपल्याला या ठिकाणी, write down a by p or असं लिहा, m is equal to a by p is equal to hydraulic mean depth or hydraulic radius. Then याच्या खालीच किंवा याच्या समोरच तुम्ही त्या ठिकाणी लिहिता येईल तुम्हाला m is equal to what, d by 4. m is equal to d by 4. After writing this, write down there I is equal to HF divided by L is equal to, काय म्हणता येईल आपल्याला, हेड लॉस पर युनिट लेंथ किंवा हायड्रॉलिक ग्रेडियंट म्हणा आधी, और हेड लॉस पर युनिट लेंथ. त्याच्या खाली लिहा Chezy's formula is given as Chezy's formula is given as V is equal to C into under root of mi, or hydraulic gradient. Slope किंवा त्याला आपण म्हणतो हेड लॉस पर युनिट लेंथ ऑफ पाईप. Now here we will solve one problem. Write down their title. Problems on head loss due to friction. Write down the problem. Find the head lost find the head lost due to friction in a pipe of diameter 300 mm and length 50 mm, 50 meter, comma, through which water is flowing. Through which water is flowing at a velocity of water is flowing at velocity of 3 meter per second using Darcy formula. Second, Chezy's formula. For which C is equal to 60. Take nu for water, that is kinematic viscosity. For water is equal to 0.01 Stokes. So as we know that this Darcy-Weisbach equation, Chezy's formula, these are applicable for the turbulent flow. So first of all, we will check whether the flow is turbulent or laminar. Okay, by finding the Reynolds number. After finding Reynolds number, you will come to know that whether the flow is laminar or turbulent. Okay, and from this Reynolds number, after that, we can find the value of F. F चे आपण रिलेशन त्या ठिकाणी दोन फॉर्म्युला लिहिले, त्या दोन्हीपैकी एक फॉर्म्युला या ठिकाणी वापरायचा आणि F फाइंड आउट करायचं. F फाइंड आउट करायचं. ओके, F दिलेला आहे का प्रॉब्लेम मध्ये? दिलेलं नाहीये. So we can find the F. After finding that F, we can use the Chezy's that Darcy-Weisbach equation to find out the head loss. Okay. So first of all, write down the given things. Diameter of the pipe is equal to 0.30. Then length of pipe L is equal to then velocity of flow then change is constant then kinematic viscosity nu is equal to 0.01 Stoke. So you know the relation between Stoke and meter square per second. 1 Stoke is equal to what? 10 to the power minus 4 meter square per second. So do the conversion of Stoke to the meter square per second. Then find out the Reynolds number. Reynolds number चा काय फॉर्म्युला आहे? Rho Vd upon mu. This is the formula. If I take this rho here, खाली जर घेतला तर मला एक फॉर्म्युला कसा लिहिता येईल? R is equal to Vd divided by mu by rho. Right? What is this mu upon rho? That is nothing but kinematic viscosity. So Vd upon nu, I can write this equation. Okay, same as been written here. Vd upon nu. Put the values of velocity, diameter, and nu. You will get the Reynolds number. Then after finding this Reynolds number, find the value of f. एक एक्सप्रेशन आपण त्या ठिकाणी लिहिलेलं आहे. Use this formula f is equal to 0.079 divided by r e raised to 1 by 4. Then you will get the value of f. What is Darcy-Weisbach equation? Hf is equal to 4 FL square upon 2 ZD. Use this formula and find out what is the value of head loss due to friction. मोबाईल मधून सेशन take the attendance. After finding the head loss due to friction by using Chezy, Darcy-Weisbach equation, you can easily find by using Chezy's formula. There is no conversion is required at all, or need to find out the value there. Yes. आलं सगळ्यांचं उत्तर HF is equal to 0.7828. Join the lecture again. Yes. Chezy's formulas being equal to C from the formula. Then is equal to equal to Chezy's formula ला आपण पाहिला तर त्या इक्वेशन मध्ये आपल्याला याचे पुढे दिसत नाही. आपण इक्वेशन कसे लिहितोय हेड लॉस ड्यू टू फ्रिक्शन आणि Chezy's formula मध्ये कोणते स्टेप घ्यायचे तर ते हिडन आहे. कसे हिडन आहे आय मध्ये हिडन आहे. आय चा फॉर्म्युला काय आहे HF डिवाइडेड बाय L हा फॉर्म्युला त्याच्यामुळे HF एक आय चा वेक्टर असतो म्हणून HF काय Find the HF by using Chezy's formula also. Has everyone got the answer? Is there any difficulty in understanding the problem? Is there any doubt? Okay, shall we stop here now? I have another lecture there, so I will close the session here now. Hmm? So I have taken your attendance. Now we can leave the session. Thank you all of you. You can compare both values of HF and HF due to Darcy-Weisbach equation and HF by Chezy's formula. Okay, let us stop here.